So this experiment is about investigating the way that a ball bounces when it hits a fixed wall. I'm going to use a small marble. I've made a ramp here using two rulers and a little bit of tape. The beveled edges go together to make a nice kind of V shape for the ball to roll down. The piece of wood here creates the wall and it's clamped to the table, and I've set this up so that it hits the wall with a velocity at an angle of 60 degrees to the wall. So let's see what happens. So you can see that the ball rebounds at a different angle, and what we're going to try and do is to predict that angle. We need to know the coefficient of restitution between the marble and the wood. So I'm going to drop the marble from a height of 40 centimetres. First we need to calculate the coefficient of restitution. To do this we need to know the speed at which the marble hits the wood when it is falling vertically and the speed at which it rebounds. First we'll find the impact speed, which I will call V1. Using the equation v squared equals u squared plus 2as, v will be v1, u will be 0 because the marble falls from rest. Because it's falling under gravity, the acceleration will be 9.8 and the distance we know is 40 centimetres or 0.4 metres. Solving this gives us v1 equal to 2.8. Next we need to find the rebound speed, which I will call v2. Again we use v squared equals u squared plus 2as. The marble is now moving upwards, so v will be 0 at its maximum height, u will be v2, which is what we're trying to find, and because the displacement and the acceleration are in opposite directions, we need to use minus 9.8 for the acceleration, and the height is 0.05. Solving this gives us v2 equal to 0.99. Now that we have these speeds, we can calculate E. E will be the rebound speed, 0.99, divided by the impact speed, 2.8, which gives us E equal to 0.35. We can now use this value of E to see what happens when the ball hits the wall. Parallel to the wall, the components of the velocity are unchanged, so V cos theta will be equal to U cos 60. Here U is the speed at which the ball hits the wall, and V is the speed at which it rebounds, and theta is the angle between the wall and the velocity after the impact. We can rearrange this to give V equals U cos 60 over cos theta. Now we can consider the motion of the ball perpendicular to the wall. V sine theta will be the component perpendicular to the wall after the collision, and that will be equal to E times U sine 60, and we get U cos 60 divided by cos theta times sine theta equals EU sine 60. We can cancel out the U's and rearrange to get tan theta equals E tan 60. Using our value of E gives theta equal to 31 degrees. My calculations came up with an angle of 31, so let's see how it goes. That was pretty good, wasn't it? Right along the line. Well, it doesn't happen quite like that every time, but I've shown you the best one.